Hello. These are a continuation of the notes that we took on Friday. Friday's notes, we talked about how we're kind of coming to the end of this Unit 6, talking about electrons and how they are behaving in the atoms and causing things like them to bond with other atoms. So now we're going to look at some of these bonds a little bit more. So on Friday in here, we talked about the three different types of bonds: ionic, covalent, and metallic. And we just started talking about ionic bonds. Now, if I'm going too fast for you, feel free to pause this. You can get all of this written down. But now let's spend a little time talking about ionic bonds. Ionic bonds, the key here are the charges. There are electrostatic forces that exist between these charges. The electrostatic forces are a lot like static electricity, where you rub a balloon on your head and that causes the electrons to be shifting around and causing some areas to be charged negatively, some areas then positively, and then you have some attractions there. So your atoms transfer some of their electrons from one atom to the other. The electrons that are transferred are the valence ones. Valence are in the outermost shell. And when they do that transferring, you cause one atom to have a negative charge and the other one to have a positive charge. And now you've got an attraction between these two. So if you look at the picture down here, we've got our sodium. The sodium had a electron that was lost or transferred over to the chlorine. Now all of a sudden sodium has become positively charged. Chlorine that gained the electron has now become negatively charged, and the two are attracted. Next slide, a little more on ionic bonds. So why or how you know if they're going to be losing or gaining or how many electrons is that these atoms are trying to reach a noble gas status. So in this last chapter, talking about electron configuration, that's what they want to reach, that really stable noble gas status. So they'll lose or gain whichever's easier to get to that noble gas status. So the metals, way over on the left side of the periodic table, they tend to lose those electrons. They tend to form what are called cations. You may see this in a matching part on a test. Cations have a positive charge. Atoms that are have lost electrons, positively charged, they are called cations. So an example would be lithium. Lithium's normal electron configuration is 1s2, 2s1. It loses just one electron to drop it down to 1s2, and now it is like helium. So metals will lose these outermost s and p electrons primarily, but also the d's if they're in the d area, and then that will cause them to have the noble gas status, be more stable, and then they'll be positively charged. Nonmetals, on the other hand, since they're so close to the noble gases, way over on the right side of the periodic table, will then gain electrons. So this gaining of electrons now, they are called anions. They are negatively charged ions. So an example will be chlorine. Chlorine's valence shell, we've got 3s2, 3p5. Again, valence is the outermost shell. By just gaining one more electron, now it's become 3s2, 3p6, and that is the same as argon. So now it is stable. So nonmetals add to their outermost p orbital to become stable like a noble gas. Again, feel free to pause if you haven't finished writing or want to rehear. All right, so moving on now. Here's a little cartoon. I think we've seen this one before, but looking at, you've got your cations and your anions. See now in your brain if you can remember. I always think of anion as being an anti type of thing. Anti and anion starting the same, so that means you're kind of negative about things. So that's how I remember anion. So right now in your brain, see if you can figure out which ones are the anions and which ones are the cations. All right, so our next type of bond is called a covalent bond. We've talked about covalent before. Key terms here: sharing, underline that, star that term. Sharing of one or more pairs of electrons. They're going to share pairs of electrons, and that sharing is the other key there. The electrons that they share, again, are the valence ones. We've been using this word a lot. Valence, again, are the outermost electrons. For the covalence case, those are the s and p electrons. So you've got two atoms that are sharing their outermost electrons, and it just makes them more stable that way. When they do this sharing, that sharing is called a bond. They can share bonds in the form of single, double, or triple bonds. We'll get into those in just a second. The other key is, remember, covalent ones are between two or more nonmetals. So two or more nonmetals, underline that as well. Star that as you're writing that down. So again, covalent bonds, we're looking at nonmetals sharing one or more pairs of electrons. When they do this, their En differences are small. Electronegativity is what En stands for. We just got into that a little bit this last chapter. Electronegativity, that tells us how they're going to want to hog or hold in those electrons. So the differences between those are going to be small. When you have really big differences, that's when you get the ionic bonds. If they're different enough, though, we have what are called polar bonds. If their electronegativities are almost the same, if not the same, then they're nonpolar. We'll get into polarity and nonpolar things a little bit next week. But the key there, again, nonmetals sharing pairs of electrons, and that sharing is making a bond. Another little cartoon for you, polar and nonpolar, referring to bears, of course. Again, we'll get into polarity a little bit more starting next week. And dealing with electronegativities as well. All right, a few more slides here. So we talked about three different types of bonds. Single covalent bonds are the first type here. Again, these are covalent, so we're having sharing going on. When two atoms share one pair of electrons, that's called a single bond. So each atom needs one more to become stable. So they're going to each share one with someone else, and then they get the one more that they need, and that makes their stable single bond. So here's some examples here. We're going to be doing quite a bit of drawing like this. So a hydrogen-hydrogen bond, okay? The dot and the X's are kind of showing this dot comes with one hydrogen, the X comes with the other, they share them together. Hydrogen likes to have two electrons by it to be stable. If you look, I've got two chlorines down here. So these are, again, the dots represent their valence electrons. The valence electrons, remember, are the Roman numerals on the periodic table above them. So chlorine's way over on the right side. It's got a 7. That's where these 7 dots come from. So it's going to match with the other chlorine of 7. They'll each share one with each other. Now they each have 8 around there. So this chlorine has 8, and this chlorine has 8. Now it makes them both stable. Next type of bond then is a double bond. Now two atoms are going to be sharing two pairs of electrons. In this case, each atom is going to need 2 to become stable. So by sharing the right amount, or by sharing these 2, they'll get their right amount of 8. Generally, only carbon, nitrogen, oxygen, sometimes sulfur form double or triple bonds. So an example would be 2 oxygens, O2, which is our normal oxygen gas that we breathe in. So oxygen has a valence of 6 electrons around it. Again, 6 is the Roman numeral on top of oxygen's column on the periodic table. So I've got the 6 from the one plus the 6 from the other. When they go together, they share 2 with each other. And again, it's giving the first oxygen 8 around it, and it gives the second oxygen 8 around it, makes these oxygens stable. And our final slide here. So again, feel free to pause if you need to catch up on your writing. Triple bonds are our last slide for today. We'll do more in here tomorrow. Triple bonds. Now we're talking about atoms that are sharing 3 pairs of electrons. So a lot of times nitrogen is a good example of this one, but there are definitely, carbon can do this, and oxygen and other atoms as well. But each atom needs 3 electrons, okay? So they're gonna, to become stable, so they're gonna share with someone else, and then that'll give them the 8. So nitrogen, fifth, 5 valence electrons. It has a 5 for a Roman numeral on the periodic table. So we've got 5 of this nitrogen sharing with 5 of this nitrogen, and together they give each other 3 to share back and forth. Now if I look here, this nitrogen's got 8 around it, and this nitrogen has 8, making them both stable. So we're at a good stopping point in our notes here. Once you have finished these, then you have a book assignment to do as well. The book assignment deals a little more with ionic type of stuff. We'll get into more covalent things tomorrow. Also, if you want to do the retake on this last test, you are going to need to do the review sheet. In order to do the retake, I need to see a completed review sheet. So the grades are posted on Skyward. You can check those out. If for some reason you're missing an assignment, like this last lab, quite a few of you, work on that as well and get that turned in. So use this time wisely to get your book assignment done, to get your any retake review sheet done or any lab work done. If you have all your work done, you have something else to work on, feel free to do that as well. But use your time wisely. I want a good report tomorrow.